we are going to talk about T&D loss and AT&C loss. What are the losses in a power system? So, do you know what T&D loss is? Can anybody tell me what T&D loss is?
T&D loss is the difference between the injected into the system and the units to be billed to the ultimate customer. Therefore, the energy input minus energy built by energy loss into 100%.
Yes. So, it is the loss in the transmission and the distribution system. And if I may, the energy flows from the transmission system to the 66 or 33 by 11 kV system. Then from the 11 kV system, it goes down through 11 by 400 volt distribution transformers to the consumer premises. So in this process, from transmission to consumer, from actually generator bus bar, from where it switchyard, it goes to the transmission, to the distribution, to the consumer, certain loss takes place, and that is known as T&D loss. So, energy can come from the EHV system to the distribution system through captive power plants, import from neighboring circle or division, interstate, and it goes to metered consumers, unmetered consumers, and export to neighboring circle division. So the difference between the two is known as losses. And how do we calculate that? We have two types. We are denoting our losses by two nomenclatures, either transmission and distribution loss or AT&C loss, which is aggregate, technical, and commercial losses. I'll explain the difference to you, but first let us do T&D loss. So T&D loss or transmission and distribution losses is the difference between units injected into the system and the units built to the ultimate consumer. And that is in terms of units. If we want to find out percentage T&D loss, then it is energy input minus energy build over energy input into 100. Is it clear? What is transmission and distribution loss? So basically it refers to the loss in the transmission and in the distribution system. And it is in terms of units and in terms of percentage. So this is how we calculate it. But where does the loss take place? आप बताइए, where does the loss take place? In your
बहुत सारे
opinion?
लोड मैनेजमेंट सही तरह से नहीं है, जॉइंट सही तरह से नहीं होता है, और थेफ्ट होता है, और डिस्ट्रीब्यूशन बोर्ड का जो मीटर वगैरह होता है वो भी सही से नहीं चेक किया जाता है, टैरिफ रिवीजन नहीं होता है, पर ट्रांसफार्मर का जो मटेरियल है उसमें बहुत ज्यादा लॉस होता है। जैसे कि सीआरजीओ यूज करता है तो सीआरजीओ में लॉस बहुत ज्यादा होता है कंपैरिजन टू एमआरएफ। सब
मैम बेसिकली टीएनडी लॉसेस जो होती है, मतलब जो जनरेट किया और जो कंज्यूमर के पास जो नहीं पहुंच पाया टोटल, स्पेशली यही हुआ टीएनडी लॉस। एंड इन सिंपल वर्ड इट इज इलेक्ट्रिकल लॉसेस आर द रिजल्ट ऑफ टेक्निकल इनएफिशिएंसी एंड जो थेफ्ट है उसकी वजह से। और टेक्निकल लॉसेस जो होंगे ऑकर होंगे ड्यू टू रेजिस्टेंस ऑफ वायर्स एंड इक्विपमेंट ऑफ इलेक्ट्रिसिटीज जो उसके थ्रू पासिस करते हैं, मेनली ये हुआ।
यस, एब्सोल्युटली करेक्ट। So it is basically T&D loss consists of two portions. One is technical loss and one is commercial loss. So what is technical loss? As you said, every element in a power system, whether it is a line or a transformer, etc., they consume some energy while performing their expected duty. What is the duty of a transformer? To transform the voltage, say from 11 kV to 0.4 kV. While doing so, they consume some energy, which is a loss in terms of units, and it is comes under technical loss. Similarly, when a current flows through a line, there is a loss due to the resistance of the line, and it is the I square R loss. So that is also a loss in the system. Cumulative energy consumed by all the elements in the power system constitute technical losses. You would agree? Every element has a loss, and the cumulative energy consumed by all these elements constitutes technical losses. The technical losses are due to energy dissipated in the conductors, transformers, and other equipments used for transmission, transformation, subtransmission, and distribution of power in all the equipments, lines, transformers. This loss is appended to a particular equipment or material and technology in use. If what I mean by this, to a particular equipment, it is inherent in, say, a transformer. It depends upon the material and the technology in use. Material, like somebody said, CRGO and amorphous. So it depends on the material and the technology in use, how it is constructed, what is the technology for that equipment. Therefore, on this losses for a particular equipment, depending upon material and technology in use. The technical losses can further be subgrouped depending upon the stage of power transformation and transmission system. As transmission losses, these are mainly in 400 by 220 kV, 220 by 132 kV, 132 by 66 kV. So all these are grouped as transmission losses. Subtransmission losses are basically either 66 by 11 kV or 33 by 11 kV, depending on the voltages used in your system. And distribution losses are from 11 kV to 0.4 kV, and the LT feeders and the service cables and the meters. So these are distribution losses, 11 kV by 0.4 kV and below. Can the technical loss be reduced to 0?
No, madam. No, madam.
Ideally,
cannot
it's
be.
possible, but practically, it's not possible.
Theoretically, yes, maybe you have superconductors, but actually there is always some resistance to the flow of current due to the material and the technology used. So the technical loss cannot be reduced to 0, but can be reduced to a reasonable level. The factors on which magnitude of technical losses depends. On what factors does technical loss depend? It can, a transformer can have, say, 10 watt, 20 watt, 30 watt. So on what factors does it depend? Can anybody tell me why the loss varies over each transformer? Supposing I have a distribution transformer of 25 kVA. Will all 25 kVA all over the country have the same loss?
No, ma'am.
No,
No,
ma'am.
ma'am.
So why will
वो
it
तो
be
वहाँ
different?
पर क्योंकि वहाँ का जो पॉपुलेशन डेंसिटी है उसके ऊपर तो डिपेंड करता है ना. सब स्टेट में तो एक
मैम
जैसा
एक्चुअली
population
ट्रांसफार्मर लॉसेस डिपेंड्स ऑन द लोड.
हाँ तो
On the
लोड तो
load,
population
on
डेंसिटी
the
का
material
निर्भर करता है.
used. on the construction of the core and the winding. You know, there are so many ways of doing a particular, making a transformer. The kind of loading we have is different for each transformer. The maker is different, so he makes different, he uses different materials. So every equipment, though it may be a transformer or it may be a line, has different losses. So the factors on which the magnitude of technical losses depends largely on the pattern of loading of transmission and distribution lines. Lightly loaded and heavily loaded or medium loaded. So the loading will decide the current flowing through the line, and it will also decide I square R. Nature of loads. What do I mean by nature of loads? Will they, when loads are different, will the loading be different? Can anybody tell me?
Nature of load means is it inductive or capacitive, resistive?
Yes, nature of load. Inductive, capacitive or resistive. So, you know, the current flowing will depend on whether it is resistive, whether it is inductive, whether it is capacitive, whether it is a combination of these three types of loads. So the combination decides the current flowing. Is it not true?
Yes, ma'am.
Yes. Design of
मैम
lines.
बेसिकली डिस्ट्रीब्यूशन
Yes.
सिस्टम में वो जो कैपेसिटी क्या आरएल लोड का ही तो ज्यादा फैक्टर है, कैपेसिटिव लोड का क्या फैक्टर होता है?
नहीं, कैपेसिटिव लोड नहीं होता. एज यू राइटली से इन डिस्ट्रीब्यूशन सिस्टम पर कैपेसिटर्स लगा दिए जाते हैं, मोटर पे कैपेसिटर लगा दिया जाता है, सो दैट इट डज नॉट ड्रॉ इंडक्टिव लोड.
लेकिन मैम वो जो कैपेसिटर का जो साइज है और कैपेसिटर का जो लोड होगा वो तो बहुत ही नेग्लिजिबल होगा इन टर्म्स
नहीं,
ऑफ
नेग्लिजिबल
रेजिस्टिव
तो
एंड
होगा.
इंडक्टिव.
See, load will not be there, but it will neutralize the kVAR drawl. इंडक्टिव जो ड्रॉल कर रहा है उसको न्यूट्रलाइज हो जाएगा ना लाइन में. जो kVAR वो सिस्टम से ड्रॉ कर रहा था वो लोकली न्यूट्रलाइज हो जाएगा बाय द कैपेसिटर. सो द it will be drawing, it will not be drawing kVAR from the system. ठीक है ना? आपको समझ आया कि kVAR जो इंडक्टेंस का होता है वो परपेंडिकुलर होता है टू द रेजिस्टेंस. kW से kVAR ऊपर की तरफ है. अगर कैपेसिटर भी लगा देंगे तो वो नीचे की तरफ हो जाएगा और वो कॉम्पेंसेट हो जाएगा और सिर्फ किलोवाट लोड ड्रॉ होगा.
तो सिर्फ कॉम्पेंसेशन के लिए यूज होता है कैपेसिटर.
हाँ,
वो जो रिएक्टिव पावर
तो लोड
कॉम्पेंसेशन
लोड का नेचर चेंज हो जाता है ना.
हाँ,
वो
वो
सिर्फ
तो होता है.
रेजिस्टिव बन जाता है या फिर
फेजर
थोड़ा सा इंडक्टिव रह जाएगा.
तो फेजर डायग्राम वगैरह चेंज होता है, हो जाता है.
हाँ, तो क्योंकि वेक्टर है इसलिए जाके कैपेसिटर और इंडक्टेंस मिलके it will become maybe resistive, maybe little inductive. It depends on the size of the capacitor. ठीक है?
Yes ma'am.
अच्छा, design of lines. What do we mean by designs of lines?
मतलब किस कंडक्टर हम लेंगे, कौन सा कंडक्टर लेंगे, कंडक्टर का लेंथ कितना होगा, उसका एसी और बहुत सारा फैक्टर है. कंडक्टर का टेम्परेचर कितना होगा, सैक क्या होगा,
एग्जैक्टली. कंडक्टर कौन सा है, ACSR 0.2 स्क्वायर इंच है, 0.1 है, 0.05 है. फिर वो वर्टिकल कॉन्फ़िगरेशन में है या हॉरिजॉन्टल कॉन्फ़िगरेशन में है या डेल्टा कॉन्फ़िगरेशन में है, उससे इम्पीडेंस चेंज हो जाती है और रेजिस्टेंस चेंज हो जाती है. So you know there are lot many factors on which the magnitude of technical losses depends, and also quality of the equipment and maintenance and construction practices. Why maintenance and construction practices? For example, if your joint is not proper, there will be resistance and there will be more loss. अगर जॉइंट प्रॉपरली डन है तो रेजिस्टेंस कम हो जाएगी और आपका लॉस कम हो जाएगा. सो मीन्स कंस्ट्रक्शन प्रॉपर होगी तो आपका जॉइंट भी प्रॉपर होगा, उससे आपका लॉस कम होगा. अगर आपका कंस्ट्रक्शन प्रॉपर नहीं है तो आपका लॉस ज्यादा होगा. इज इट ओके?
यस मैम.
Yes, madam.
So if we talk about loss in conductors and cables, it is due to the loading of the line. Once there is a given configuration and design, the loss will depend on the loading of the line, which will be I square R loss. Is it okay?
Yes, ma'am.
Yes, madam.
Then there can be a loss due to unbalanced loading. Would you agree with me कि when there is an unbalanced loading, we have a three-phase system, तो three-phase system, four-wire system में unbalanced loading होगा, तो loss will be more than in a balanced system. Do you think so?
Yes,
Yes
madam.
ma'am.
What will happen, because current is vector, there will be, if the load on all the A, B, C phase or R, Y, B phase are balanced, then the vector sum of these currents will be zero. There will be no current in the neutral. Would you agree?
Yes, madam.
But if there is unbalanced loading, then there will be current in the neutral also. So there will be additional loss for the current flowing through the neutral, which will again have an I square R loss. And there will also be higher loss in the unbalanced, higher loading phase wires. Would you agree?
Yeah, ma'am.
Yes, madam.
So, you know, in our system, why does this happen? See, we have a LT feeder with three phases and one neutral. When you start giving connections, you have a tendency, any lineman or JE has a tendency to give a connection from the lowest phase. Vertical configuration hai, he will try to give from the lowest phase.
Yes, madam.
Delta configuration hai, he will try to give correction from the lower two phases and neutral. So single phase loads will be drawn, connections will be given from more from the lower phases than from the upper phases. So they, and you know, it is very difficult to balance load, that how much have you given, what is the actual load. So therefore there is always an unbalance in loading on the phases. So one is like I told you, on the design of the line, the kind of equipment, etc. But another loss occurs due to unbalanced loading.